Hello students. Now we are going to see the next topic, that is Warshall's algorithm. So if R is a relation on set A, then its transitive closure is denoted as R star. We already saw what is the concept of transitive closure. It is nothing but the minimum number of pairs that are to be added in the original relation to make it transitive. So here, in many cases, if the relation is quite large, which contains vast number of tuples, then it becomes a tedious task to obtain the transitive closure. Also, in some cases, addition of new tuples to the original relation triggers a chain of transitive pairs. Hence, there are various ways defined to find the transitive closure of any given relation. So they are the digraph approach, adjacency matrix method, and Warshall's algorithm. So today we are going to see the Warshall's algorithm to find transitive closure. So let's take an example before we define the steps. Let A is the set that is given to us and R is the relation defined on set A. We have to find the transitive closure of R specifically using Warshall's algorithm. So firstly, what you have to do, you have to convert the given relation R to its corresponding relation matrix. So we have already seen this concept in the previous video, representation of relation. Here, the relation matrix, the rows correspond to elements in the first set, that is 1, 2, 3, 4, and columns correspond to the elements in the second set, that is also 1, 2, 3, 4. Then we mark an entry as 1 if that particular tuple is present in the relation, like 1, 2, then 2, 3, 3, 4, and 2, 1. So I've marked them 1, other entries are marked as 0. So that is the first step. Next step is consider the first row and first column in relation matrix. So here, this is your W0. MR is nothing but your W0. Now, observe the values of ones in the first column. First column is this. Observe the place of 1. So 1 is here in the first column. Write down its corresponding position. So it is present at second position. Then observe the value of ones in the first row. So first row is this. 1 is present here. Mark its, write down its position. So it is also present at position 2. Now, whatever positions you got, you create a tuple, form a tuple corresponding to these positions. The form tuple is 2, 2. So, whichever tuple you get, you mark a 1 in this particular position corresponding to W0. So, in W0, which is the position 2, 2? This one. So mark this position as 1. If it is not already 1, then you will get the new matrix W1, which will have 1 in that particular position. Okay. So a very important thing to note here is that you first take the position of 1 in column and then take the position of 1 in row. Okay. Then now you obtain W1. Now in the next step, you will consider row 2 and column 2 in W1, not W0. So now in W1, consider column 2. In column 2, find where there are ones. So at 1 and 2, mark it Then next, consider row 2. Find the position of ones in row 2. It is 1, 2, and 3. So write it down and then form pairs of position in column and position in row. So 1 with 1, 1 with 2, 1 with 3. Then 2 with 1, 2 with 2, 2 with 3. So now you will obtain these tuples. So what you have to do, you have to mark the position as 1 if it is already not 1. Okay. So now we will obtain W2. So here if you see, this blue circle represents the newly obtained ones corresponding to these positions. So 1 1, 1 2, 1 3, 2 1, 2 2, 2 3. So I mark them as 1. Now in the next step, again I will consider row 3 and column 3, but the matrix that I will see is W2. Okay. So now in W2, I will see the value of 1 in column 3. So column 3 has 1 in 1, 2, and in row 3, I have 1 only at 4. So I form the tuples. What I'll get? 1, 4, and 2, 4. So 1, 4, and 2, 4, I will mark as 1 in W2. And I will obtain the new matrix W3. So these are the positions that are updated after making this position as 1. So 1, 4 and 2, 4. Fine. Now you obtain W3. Consider the same W3, pass it to the next iteration. Now I'll consider row 4 and column 4. So now in W3, the value of ones in column 4 are 1, 2, and 3. Right? 1, 2, and 3. Whereas in row 4, but row 4 does not have any 1. So that means it is not applicable. So can you actually form any pairs? It's not possible. So you don't perform any change. You keep W3 as it is. The same will be your W4. W3 is equal to W4. And this is the actual final relation matrix that is obtained. So how many steps do you need to perform in this algorithm? So that is nothing but the number of rows that are present in your matrix. Those many number of steps you have to do. So here W4 will be your last matrix, which will give you the transitive closure of your relation R. So when you convert this W4 into a relation, so how to convert it? So this is 1 1, 1 2, 1 3, 1 4, 2 1, 2 2, 2 3, 2 4, and 3 4. So this is your transitive closure denoted by R star, and it is in the relation form. So in this way, I can obtain the transitive closure of a given relation using Warshall's algorithm.